Hello everyone. In this session of Ccna series, I'll discuss ACL types. There are two common types of ACL. One is standard ACL and another one is extended ACL. Standard ACL filter traffic based on source IP address, whereas extended ACLs filter traffic based on multiple parameters such as source IP address, destination IP address, protocol type, and port numbers. And then again, based on ACL naming methods, we can classify ACL as numbered ACL or named ACL. Number ACL is the traditional naming method, like after an ACL is created, a unique number is specified for the ACL, whereas an named ACL is an ACL identified by a name or number for identification. We'll discuss about it in the upcoming slides. So we'll start with standard numbered ACL. To configure the standard number ACL, it uses numbers rather than names. Standard numbered ACL uses the range of numbers between 1 to 99 and 1300 to 1999. So the basic syntax for configuring a standard ACL in Cisco IOS is you start with access list, the command to create an ACL entry, then the number assigned for the ACL. For standard ACL, as I said, numbers from 1 to 99 and 1300 to 1999. And then you have permit or deny statement, which specifies the action to take for the matched traffic. Permit allows the traffic while denies blocks it. Then you have the source IP address to match. Then we have the interesting part, that is the wildcard mask. The wildcard mask is used to apply for the source IP address. This mask determines which bits of the source address to consider in the match. I'll discuss about wildcard mask in the upcoming slide. Before that, let's take an example. Uh, this is the example access list. 10 access list, as I said, is the command. 10 is the number, and then permit is the whether you want to allow the traffic or deny the traffic. Since we want to allow, we'll use permit. And then we have at the end, after permit we have an address range 192.168.1.0/24, but here instead of subnet mask we are using wildcard mask 0.0.0.255. So what is wildcard mask? A wildcard mask is a technique for matching specific IP address or range of IP address. Okay, so wildcard masks are used in ACL in networking to specify which bits of an IP address should be matched exactly and which bits should be ignored. So wildcard mask plays a crucial role in defining IP address ranges in ACL. There are actually the wildcard mask is the inverse of subnet mask. When I say inverse, a subnet mask specifies which part of an IP address is the network portion and which part is the host portion. Similarly, a wildcard mask does the opposite. It specifies which bits should be ignored, that is, I can say wildcarded, and which bits should be matched exactly. Let's take an example. Before we take an example of 192.168.1.0/24, let me share you one formula to calculate wildcard mask. What you have to do is you have to take the broadcast address, that is 255.255.255.255, subtracted by the subnet mask. In this case, we have subnet mask as /24. In the decimal dotted format, it's 255.255.255.0. So subtract the broadcast address to your subnet mask and you are getting the wildcard mask. It's that simple as. And if you have to take a complex subnet, like for example /28, again subtract it by broadcast address, and for /28 you have 240. So 255 minus 240 is .15. So your wildcard mask is 0.0.0.15. So with that, let's move on to how to match the exact IP address and ranges using wildcard. To match a specific host, you can just write the entire IP address in standard access list. You don't need to type anything. Just type access list 1 permit and then type in the address. You will get, sorry, for host. In case if you want to match a range of IP address, you can use tool called wildcard. So this is where it is used. And here if you see, I have a subnet of 10.1.1.0/24. So I'll use this wildcard mask, sorry. Then another interesting feature in access list is actually in Cisco ACL there is an implicit deny all rule at the end of every access list. This means that if a packet doesn't match any of the explicitly defined rules in the ACL, it will deny it by default. The implicit rule is not visible in the configuration but always applies. If you see the access list, you will not see it. It is not visible, but it applies. And if you want to remove this or override this default behavior, you can type in permit any at the end of the ACL. That's why you will find this command in most of your ACL. Actually, it's important to configure permit any at the end of the access list for packet to pass through without any action. So if nothing matches, then it will allow. Let's move on to another access list called extended number IP ACL. Extended ACL filter traffic based on multiple criteria such as source IP address, destination IP address, protocol type, and port numbers. It uses numbers from the range of 100 to 199 and 2000 to 2699. Just like standard IP ACL, you enable extended access list on interfaces for packet either entering or exiting the interface, since it can use large variety of packet header fields to match a packet. So one ACL statement can examine multiple parts of the packet headers, requiring that all the parameters be matched correctly to match that one access list element. And the basic syntax for configuring extended ACL is, first you start with the command to create an ACL entry, then the numbers, then whether permit or deny, action to be taken to allow or block the traffic. Then you have protocols to match. This is the important part. Here you can match protocols such as IP, TCP, UDP, ICMP, etc. Then you have source IP address to match, and then wildcard mask of the source. Similarly for destination, here another important thing is from standard access, here you can match destination IP address as well. And then you got operator. Actually, the comparison operator used for port numbers. For example, if you want to match particular port, you can use equal to, or if you want to match port numbers, a lot of port numbers like greater than or less than, you can use those symbols as well. Then you have actual port number. You can examine port parts of TCP and UDP header, particularly the source and destination port number fields. The port numbers identify the application that sends or receives the data actually. And for example, like web users, they use well-known port number 80, so you can define that. So let me take an example of extended access list. Actually, the FTP server is sitting on the right, and client is sitting on the left. To permit the communication from client to server, we're using HTTP, and the access list for that is to permit HTTP traffic from the particular subnet. Access list permit TCP 172.168.1.0/24 is the client subnet, and then the destination subnet is 172.168.3.0. So this access list allows TCP connection from source to destination with port number equal to 21. So here you are matching A subnet, right? If you want to match a specific host, you can type in this access list. On the source side, you can type in host with exact IP address. This will allow only that host. So let's move on to the another access list classification. Not another actually. We discussed about standard and extended, and these standard and extended lists either you can configure as a numbered access list or named access list. So this is the named access list. This is type of ACL identified by a name or rather a number. So you can use it for standard or extended, and it is more user friendly and easier to manage, especially in large networks. So named ACL allow for dynamically adding or deleting ACL statement without having to delete or rewrite all the lines. And some of the benefits are readability, where numbers are easier to remember and describe the ACL purpose better than, names are easier to remember and describe the ACL's purpose better than number. For example, if you want to block a particular section, you can write the ACL by using that section name. Then manageability. Modifying and troubleshooting ACL is simpler with, as I said, name. For example, if you want to block certain department, then it's easier to create an access list using that department's name, block that department. Then you have flexibility. You can create and modify named ACL without needing to delete and recreate the entire list, unlike numbered access list. Numbered access list, if you want to edit something, you have to rewrite the entire access list. And named ACL also allows the CLI user to delete individual lines of the ACL and insert new lines individually. So the syntax for named ACL is IP access list. You can type in as a standard or ACL and name, or you can, if you want, you can type number as well. But another interesting part is when you type in this command, it will take you to the ACL configuration mode, in which you can add your rules. For example, if you see the syntax, it permits or denies, and then you can use the source along with the mask. So when you configure the ACL, it will look like this. For example, IP access list, I'm using standard, blocked so and so LAN, and deny this, and then later on permit any, because permit any is required. Because there is an implicit deny, right? Invisible deny, as I said. Then I'll show you how this editing ACLs. For example, if you see here, uh, the ability to edit a numbered ACL actually was really poor, right? But name ACL improves in that part. For example, to simply delete a line from the ACL, the user had to delete the entire ACL and then reconfigure it. But here, you can use sequence numbers that allows for easier management and modification of ACL entries without needing to recreate the entire list. The ACL editing feature uses ACL sequence number actually. That is added to each ACL permit or deny statement with the numbers representing the sequence of statement in the ACL. If you see on the right part, after configuring the ACLs, if you see below, it shows numbers. These numbers are automatically added. They are called ACL sequence number. The ACL sequence number provide the following benefits for both numbered and named access lists. Actually, it helps you delete single lines. An individual ACL permit or deny statement can be deleted with no sequence number subcommand. If you see on the right, I have used no deny so and so IP, which will automatically delete it. Also, you can use sequence numbers. So inserting new lines also is easier. Newly added permit and deny statement can be configured with sequence number before the deny or permit command, dictating the location of the statement within the ACL. You can also type in particular sequence number. I'll show this in the access list configuration lab. And last one, it automatically adds the sequence number when you configure the ACL. So it will add, like for example, with a gap of 10. Even that can also change by using some command. So at the end, let's see ACL implementation and consideration. First is like regarding extended ACL. You have to place extended ACL as close as possible to the source of the packet. This strategy allows ACL to discard the packet early. Then place standard access list as close to destination as possible, because standard ACL look only at the source IP address. They tend to filter more than you want to filter when placed close to the source. That's why it's better to place it closer to the destination, because this strategy avoids mistake with standard ACL, which matches the source IP address only, of unintentionally discarding packet that did not need to be discarded. Then place more specific statement early in the ACL. By this, what I mean is, by placing more specific matching parameters early in the list, you are less likely to make mistakes in the ACL. For example, imagine that the ACL first listed the command that permitted traffic going to 10.1.1.0/24 subnet mask, right? And then you add the command which denies traffic going to host 10.1.1.1. Now, packet sent to host 10.1.1 would match the first command, because it will allow, because whenever the first match is made, the access layer is completed, right? So you have to make sure to avoid such mistakes. And the last one is disable an ACL from its interface using the no IP access group interface subcommand before making changes to the ACL. This is the important consideration to make, and these are the points you need to remember when you configure ACL. That's it for this session. I hope this was